Hi friends, I am Engineer Venkatesh, Assistant Professor in Rohini College of Engineering and Technology at Kanyakumari District. Now we are going to see a topic in remote sensing. So the topic title is Motion of Planets and its law. Generally, planets and satellites move in an elliptical path around the body that they orbit. Orbit is the path of a body as it moves under the influence of a second body. For example, is a path of planet or comet is moves around the sun. Planets and satellites that orbit that bodies drag out a path called an ellipse. Planetary motions as well as the satellite motion is governed by Kepler's laws and Newton's laws of gravitation. The Kepler's law of planetary motions. So Kepler formulated three laws of planetary motions which describes the orbit planets around the suns. The three laws are described below. First law, the law of ellipse, states that the path of each planet around the sun is an ellipse with the sun at one focus. Second law, the law of equatorial areas, states that the line that connects a planet to the sun sweeps out the equal areas in equal time. That is, the aerial velocity of the planet is always constant. Third law, the law of period, states that square of the period of revolution of any planet around the sun is proportional to the cube of the semi major axis of the orbit. So generally, another one law, the law of ellipse. So Kepler's, it is referred as the Kepler's first law. It explains that the planets are orbiting the sun in path described as an ellipse. The two other points are known as the foci and ellipse. The law of equatorial areas. It is referred as the second law. It describes the speed at which any given planet will move while orbiting the sun. The speed at which any planet moves through space is constantly changing. A planet moves faster when it is closer to the sun and slowest when it is further from the sun. And the third law, the law of periods. It is referred as the Kepler's third law. Compared to orbital periods and radius of the orbit of the planet of those of other planets. So the comparison between made is that the ratio of square of the period to the cubes of their average distance from the sun is the same of every point of the planets. So next, Newton's law of gravitation. So every particles of matter in the universe attracts every other particles with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. So here Newton's law of gravitation is also referred as the law of universal gravitation is the fundamental principle that describes how two objects with mass attract each other due to the force of the gravitation. So the law was formulated by Sir Isaac Newton. According to him, the mathematical expression for Newton's law of gravitation F is equal to G into m1 into m2 divided by r power 2. Okay, so here r is the distance between the center of the two objects. M1 and M2 are the mass of the two objects. So G is the gravitational constant, F is the gravitational force. So here, according to this, the main key points of Newton's law of gravitation are inverse square law, proportional to mass, universal, and applicability. Okay, so first inverse square law. The force of gravity decrease with the square of distance between the object. Next, proportional to mass. The force of gravity is directly proportional to the product of the masses of the two objects. Next, universal. Newton's law of gravitation applies to the all object with mass is in the universe. Last one, applicability. For most practical purpose, Newton's law of gravitation remains highly accurate and it is still used in many calculations. So next, orbital elements. So orbital element is The path of satellite revolving around the Earth is known as orbit. So the path can be represented with mathematical notations. Orbital mechanism is study of motion of satellite that are present in the orbit. So the orbital elements are the parameters which are helpful to describing the orbital motion of satellite. So the following orbital elements are semi-major axis, eccentricity, mean anomaly, arguments of perigee, inclination, right, occasion of ascending nodes. So first is semi-major axis. The length of semi-major axis A defines the size of the satellite orbit. It is the half of the major axis, so it is radius of orbit and the orbit of two most distant point. Next, eccentricity. The value of eccentricity E fixes the shape of the orbit, satellite orbit. This parameters indicates that the deviation of orbit shapes from the perfect cycle. So that is E is equal to A square minus B square. Next, mean anomaly. Mean anomaly gives the average value of angular position of the satellite with reference to perigee. Next, argument of perigee. Satellite orbit cuts equator planes at 2 points. The first point is called descending nodes, where the satellite from the north hemisphere to southern hemisphere. The second point is called ascending nodes. The satellite passes from southern hemisphere to northern hemisphere. So argument perigee is the angle between ascending nodes and perigee. Next, inclinations. The angle between orbital planes and Earth equator plane is known as inclination. Last, right ascension nodes. So right ascension nodes is the angle between line of Aries and ascending nodes towards east direction in equatorial plane. Aries is also called as ventral and equatorial.